Today we have proposition 8 of book 3, and it's actually 3 propositions in one. They're very much related to each other, so it's easier just to do them all together. Okay? First set, second set, third set. If, then it's all the same circle set. If there be a circle, and a point be taken outside of that circle, and lines be drawn from that point to the opposite side of the circle, the concave, so this is the circle going all the way to the concave part. From that point, passing through both sides of the circumference and landing at the concave circumference, the line which passes through the center will be the greatest, and of the other lines, the nearer to the center will be greater than the more remote. Now, of that same circle, thinking about the lines falling upon the convex of the circumference, this part. Of the lines, of all of them, the line that eventually passes through the center, that part between the point and the convex circumference will be the least. And of all the other lines that fall on the convex of the circumference, the more near to the least will be lesser than the more remote. Third thing. And of points falling on the convex of the circumference, those falling on either side of the least, that is to say, the one passing through the center, there will be one equal to the other, and only one, not two, not three. Okay. So we're going to do these 3 props in one right now. Here we have a circle and the center, and a point outside the circle. Let's drop some lines to the concave of the circumference all the way to the other side. One passing through the center, and after it passes the center, let's make it dotted. Okay? And of the others, not passing through the center. And let's do one more. Okay. Thus, it is required to show that this line passing through the center is the greatest of the 3, and any others, by the way. And this one, red one, will be greater than the blue one because it is more close to the center. It's closer to this one line passing through the center, okay? So let's start by making some, this is the center, remember? So let's make some other radii. Connect these dots and connect these 2 dots. Okay, now you see you have a triangle here and a triangle here, okay? Now, these are all radii of the same center, of the same circle, radii of the same circle, of the same coming from the same center. So they're equal to each other, okay? So, if this is equal to this, then, and in this triangle, this and this are greater than this because in any triangle, 2 sides taken together are always greater than the third. So in this triangle, this and this are greater than this, okay? But this is equal to this. So if this and this is greater than this and this must also be greater than this. 2 things equal to the same thing or equal to each other. 2 things which are equal to each other, one being greater than the other will be greater than the other as well. So if this and this are greater than this and this are greater than this because this is equal to this. Great. So we just showed that this line passing through the center is greater than this line not passing through the center. That's one case. Now let's show that this one is greater than this one and being more close to the center. Okay? So let's look at these 2 triangles here. Okay? Here we have 2 triangles with 2 sides being equal to 2 sides because remember these are radii of the circle. So in this triangle, these 2 sides are equal to these 2 sides in this triangle. Okay? But this and this, so now we have 2 triangles with 2 sides equal to 2 sides, and one of the angles is greater than the other. One of the angles this angle is greater than this angle. So you have this triangle with this being an angle, and this triangle with this being an angle. So in these two triangles, remember, this and this are equal to this and this. We know in any two triangles, if two sides be equal to two sides, or one of those two set of sides has an angle greater than the other, then that base opposed or subtending that greater angle will be greater than the base subtending the lesser angle. Okay, if this is equal to this, and this is equal to this, and this is greater than this will be greater than this. Two triangles, two sides equal to two sides, one of them having a greater angle, the one with the greater angle will have a base greater than the one with the lesser angle. So this has the base greater than the one with the lesser angle. So this is greater than this. So we've shown then, in this circle, with a point being taken outside, that the line landing on the concave circumference that passes to the center is the greatest, and of all the other lines, the ones closer to the greatest are always greater than the more remote. Now let's do the same sort of thing, but we're going to talk about lines which fall on the convex of the circumference. They're still going to go through the center. We're going to do kind of opposite here now. Here's our point. Let's have one go through the center. We're going to have it go dotted until it goes to the circle. Now that's our center. Okay? And again, dotted. Not going to the center. And another. Not going to the center. Okay, now I'm going to talk about these lines. Here's the point outside, here are the lines falling on the convex of the circumference. I say of all those lines, the one that eventually passes to the center, we extend that, it passes the center. So this line, it's required to show that this line is the least of the 3 or 4 or 5 or 6 or 7, however many you have. And of the others, the ones closer to the least are always less than the ones more remote from the least, okay? So let's talk about these two lines. Great. How can we do this? Do I want to connect this? How do I want to? Oh, I'll connect from the center because then we'll have equal. So let's go. Gotta make sure I'm going to do this right. Connect that from the center. Maybe that'll work. Yeah, that'll work. So let's. Good. Now, here we have a triangle, and these two sides are going to be greater than the third. Okay? So this will be greater than this this. But these two are equal. These two lines are equal because they're radii of the same circle. So let's take equals from unequals, and they will remain unequal in the same way. So if this and this are greater than this, and this is equal to this, the remainder will still be greater than the remainder. Okay? So I've shown that this is less than this, but I got to show, I got to show that this is going to be the greater. Let's see here. Greater angle. I'm going to somehow show this is a greater angle. I got to figure out how to do this. Give me a second here. I'm going to show that this one is greater than this one. Do another color, purple second. Here we have a triangle and two lines meeting in the center of that triangle. So we know that those two lines meeting in the center will be greater than the other two lines. Sorry, less than the other two lines. Remember that? In any triangle, when you take two lines and they meet in the center, from that base, those two lines will always be less than the other two lines. So these and this is less than this and this, but this is equal to this. So let's sack out equals from equals. The remainders will be unequal in the same way. That is, this will be greater than this. So we got this being greater than this, and this being greater than this. We got to show that this is the least somehow. How can I show that that's the least? I forgot. Anyway, let me try to get back to that in a second. That's at least. I guess you just keep going and going and going, and when you go to the other side, you get the same situation. Okay? Any line coming over here will always be less than this line, the one going to the center, like here. So over here will always be greater than this. Over here will always be greater than this, so this must be the least. There's probably a better way to explain that, but I can't think of it right now. Okay, so let's do now the point where we have the same point outside, lines falling on the convex of the circumference. Okay. Great. Now I say that there'll be a line over here that can be equal to this line. Great. How? Let's make an angle equal. So let's draw a line with an equal angle here. You know we can do that. Okay. And let's, from the center, make connections. From the center, make connections here. Okay. And something like this. Make connections. Okay. I say that this, because they're equal angles, will be equal to this. For if not, let's do a reduction. One of them will be greater. Let this be greater than this. So let's cut from this a line equal to this. Great. And let's connect them with maybe D. Okay. So here we have two triangles with what am I trying to do here? We're showing that this is not less than this. Okay. With two sides. Let's see here. I want to show that this. Okay, I got this equal to this. And I think I'm going to connect them here. That's not going to work. This equal to this. I'm going to have to go and study this one. I forgot this one. So we'll put a little pause and I'll give you part 2. Okay, one moment. Great.